Hi there everybody, this is lesson 3.2.3 and we're going to talk some more about similar triangles today and congruent triangles. Actually the congruent part we'll do in class, and you'll get some more practice with the flowcharts that you learned in yesterday's video. We're going to start with 64 part C. I'm going to have you practice A and B in class, so let's start with 64C. We want to see if these triangles are similar. So what should our plan be? All good flowcharts for triangle similarity, will start with a plan. Your plan is either going to be one of two things. It's going to be angle-angle, or it's going to be side-side-side similarity. So the question is here, which one will that be? Well, we don't have information about any angles. No angles here. All the sides are what we have. So we've got no way of finding any of the angles either yet. We will actually later in the course be able to find some of these angles with some more advanced concepts. But for now, we can't find any of them. So our only choice for a plan is side-side-side, because all we have information about are the sides. That is it. So let's write down our plan here. Side, side, side. And the plan tells us that we need 3 pairs of ratios, side ratios, that are the same. Don't need to worry about any angles. So let's take a look here. 8 is the smallest side in this triangle. The smallest side down here is 4. So those are corresponding. We'll say 8 over 4. And 8 divided by 4 is 2. That reduces to 2. So there is one pair of sides that give us a ratio. The biggest one up here is 14. The biggest one here is 7. Now, should I do 14 over 7 or 7 over 14? Or does it matter? Well, actually it does matter. Since I did the big triangle over the little triangle here, I have to do the big triangle over the little triangle for all of the ratios. I could have done 4 over 8 here. That would have been okay. Then I would have had to done small over big for the other 2 ratios also. You just have to be consistent. I did big triangle over little triangle with this first ratio. I'm going to do big triangle over little triangle for all of them. So 14 and 7 were the biggest, we said, so we'll do 14 over 7, and that is 2. Now if those are different, if those were different ratios, I'd be able to stop and say, nope, not similar. But we've got 2's here. They are the same, so we got to keep going. Are we done? Can I automatically now say that they're similar? Well, no, because my plan says that we need 3 pairs of sides. See, I haven't written anything under this part of the plan yet. That's why we do this, to remind ourselves how much information that you need to have. We need 3 pairs of side ratios that are the same, or 3 side ratios that are the same. We have 2. We need 1 more. So let's look here. We've used 8 and 14. 9 is the only one that's left here. 5 is the only one that's left on the other one. So we'll go 9 over 5. And 9 divided by 5 is 1.8. Is 1.8 or 1.8 and 2 the same thing? No, they are not. In order to be similar, all 3 of these ratios have to be the same. So since they're not all 3 the same, these triangles are not similar. And we'll write because all 3 side ratios are not the same. If we'd have gotten all 2's, we'd finish our flowchart and they would be similar. But since we got something that was different, we know those cannot be similar. So that one is done. We don't even need to finish our flowchart because, again, they're not similar. You only use the flowchart to show that things are similar. If you figure out in the middle that they're not, stop your flowchart and just say they're not similar, and then explain why. Let's look here at part D. So here is another pair of triangles. We don't know this length over here, and we don't know this side over here. If this were a right triangle, the only way, and that's really the only way we can find missing sides in triangles right now, is if it's a right triangle. If it's a right triangle, you can use Pythagorean theorem to find a missing side. Hint, hint about part B tomorrow. You might keep that in mind for part B when you do that in class tomorrow. But we have no way of finding these sides unless these are right triangles. And we don't know that these are right triangles. So we have no way of finding these lengths. So even if we wanted to use side, side, side here, we couldn't because there's no way of checking actually two of the ratios. We couldn't 5 divided by what? I mean, we don't know what it is. So we can't check that ratio. So side, side, side is not going to be the way to go here. Now you might think, well, wait, we only know information about one pair of angles. So why would angle, angle be any better? But you've got to look closely. Because there is an angle in that diagram that is in both this triangle and the big triangle, the small one and the big one. Do you know which one it is? Angle M. Angle M is an angle in this small triangle. It's also an angle in this big triangle. So it must be the same in each of those triangles because it's the same angle. So that one is our second pair of angles. And so there we know our plan should be angle, angle. So which angles? We said angle M was one of them. So let's write the measure of angle M equals the measure of angle M. That sounds kind of funny, but I mean, it's the same point, so I'm not sure what else we could call it. There's one pair of angles. Our plan tells us we need one more pair of angles, and that's these. So this one we can call V, measure of angle V equals. Now, can we say angle S here? The answer is no. You can't say angle S because there's two different angles here at point S. So if you say angle S, I'm not sure which angle here you're talking about. So you've got to be more specific. You've got to name it with 3 points. So we'll say angle MSN. Angle MSN is another name for this, or is one name for this angle. You could also call it angle NSM, and that would be okay too. Either way is fine. As long as the S is in the middle, you can write those letters either way. So we are done with our plan. We needed 2 pairs of angles. We've got 2 pairs of angles being the same, so we're done with our plan. So we're ready to say that the triangles are similar. So let's see, let's call this smaller one, let's call it triangle MSN. MSN. Is similar to, remember to use that similar symbol. Now I started with M here, and M in the small triangle corresponds to M in the big triangle, so we'll start with M here. Next we used S, and in the big triangle that would be V, so we'll go V next. And then we ended with N is the only one left in the small one, T is the only one left in the big one, so we'll say T. Again, we'll draw a oval around that to keep it separate from those other ideas. Now we used these 2 statements to draw this conclusion that the triangles were similar, so we'll draw arrows. Are we done? I really, really hope you're screaming no. Maybe not screaming because if it's late you might wake somebody up, but you are definitely not done. There's a little thing right here that you need. You just need to justify this last statement. And the justification is always the same as the plan. So that makes it real easy. Angle, angle, similarity. Don't forget this symbol here. Don't just write angle, angle. Write the symbol in there as well. So that is our flow chart for part D. We'll finish number 64 and move on to some talk about congruent triangles as well tomorrow in class. Hope you have a wonderful evening. We'll see you soon. Bye.